Hi, welcome to everybody who's joining us this morning or afternoon, depending on where you are. Um, we're going to give just a few minutes. It's a very small group so far, so we'll give a few minutes for others to join as well. Um, so while we're waiting, I'd love for you to let us know any questions that you have. You can put them in the chat or type them into the poll box. Um, you can see on the screen there's a few terms that we've been looking at this week in Unit 3. So if that maybe jogs a question in your brain, please let us know any questions that you have for today. Thanks, Kate. Um, Welcome, everybody. I was talking and on mute, so apologies for that. Thanks, Kate. I appreciate it. Welcome, everybody, to office hours today. Um, As we're getting started, if you would please type any questions that you might have either into the poll box. I'm going to leave it up for a few more slides. We've got one question, which is very helpful, but please type any questions that you have into that poll box. Or if you have questions after I take that down, you can just type your questions into the chat. We'd love to base today's discussion on your questions or on the topics that you'd like to hear about today. Any parts that you felt were confusing or challenging, we'd love to be able to talk about those more today. So we'll be going through a lot of pump selection, but also any other part of the course that you've gone through so far. We'd be happy to answer questions about. All right, so office hours. So glad all of you could make it today. Just a few reminders. We use the same link every week. So you can always find that in the course announcement. Um, and sessions will be recorded and posted. So if you're watching back this recording, you've found that. But if those on the call today can't make it for the whole call or you miss one week, just know that you'll always have access to the recording if you want to go back and view that. Okay, so where we are in the course. So we just are finishing week 3, which is unit 3 on pump selection. And then next week we'll move into the solar array. But this week is all about pump selection, inverter selection, and power requirements. So hopefully some of you have been able to make it through that unit. If not, that's okay. We'll go through a little bit review, but it'll be maybe a nice introduction to get you excited to going through it when you have the time. Okay, so I'm going to go ahead and take down our questions poll. Thank you for those who did type in a question. If you have a question that you didn't get to place in the poll, feel free to put that in the chat. All right, so quick kind of show of hands. Um, where are we in the course or how are we feeling about some of this material? So have you gone through most of Unit 3? Okay, that's great. Do you feel confident in selecting a pump? Or some parts confusing? Or you maybe still catching up on some earlier units? Okay. Looks like most of us on the call have gotten through Unit 3. That's great. That hopefully will lead to some good discussion this morning, maybe some more questions. A reminder that if you are still working through maybe Unit 2 or even Unit 1, you do still have access to all the course material for the full course. Um, and so you'll be able to catch up. So just know that you can go at your own pace, but we do just encourage you to try to keep up as best as possible so that you can participate with us on these weekly calls and in the discussions. It's a little easier to engage actively when you're kind of in line with the course schedule. It will also keep you from being overwhelmed at the end when you're trying to rush to finish everything. Okay, so we are going to go back just a little bit and do some Unit 2 review. We had a lot of really good discussion last week on particularly pump testing and abstraction. And then I want to make sure we also get a chance to talk a little bit more about step 3, which is more the design flow in TDH, and make sure that we answer any questions related to Unit 2. Um, so I want to do just a quick check on how everybody is feeling about that unit. So let me launch this. And if for each one, you'll just kind of rate how you feel about these items. So how confident do you feel with how the abstraction rate affects our designs? How confident do you feel knowing what to consider about water quality for our designs? How to calculate the design flow rate, and then how to calculate the TDH. So if you'll just give those kind of a quick rating from like not confident to very confident. Okay, thanks for votes, everybody. That's helpful. Oh, I'm sorry, everybody. I've launched. Okay. let me go back for a second. Apologies. Um, I grabbed the one for today. I want to go back to last week though. Okay, apologies. Please respond to this poll. So these questions are related to Unit 2. So just want to go back a little bit and check how everybody's feeling about Unit 2 before we move on. And then again, if you have questions related to Unit 2, now would be a great time to either type those in the chat or raise your hand. It's a very small group today, so lots of time for us to be able to unmute and ask questions if we'd like to. Okay, so we have at least one of you feels very confident in all of these areas. That's great. Um, Another feeling pretty confident in these areas. That's good. You know, a lot of these topics are also similar for other water systems, even if they're not solar powered. And there's just a few details or changes we have to consider when we are looking at a solar powered water system, especially with design flow rate and how we calculate that. Um, so they might be very similar concepts to what you've already been doing in other water systems. So it looks like most of you are feeling either very or confident or very confident. And so that's good. Does anybody have a question related to Unit 2? So pump test, design flow rate, TDH, any questions related to those topics? Anything you'd like to hear more about this morning? Okay, all right. Then we'll go ahead and proceed um, into our Unit 3 review if everybody is feeling confident about Unit 2. Okay, then I am going to pop up the poll. Um, I know some of you answered it already, but I'm going to ask you to answer it again. Let me relaunch this. Okay, so then these questions are related to what we've done in Unit 3. So again, if you'll just give a quick rating to these items. So selecting an appropriate DC pump for solar power water systems, selecting an appropriate AC pump, selecting an appropriate inverter, and then determining the power requirements of each of those. So after going through Unit 3, how are you feeling? Thanks for those of you who responded. That's very helpful. I'll give a few more minutes for everyone else to be able to respond. It seems like we're feeling very confident with the pump selection, both for DC and AC, but maybe a little less confident with our inverter selection and finding the power requirements. And that makes sense. We have to selecting a pump is probably something that's more familiar to a lot of us, especially an AC pump, if we've been doing non-solar water systems. But things like inverters, and especially finding the power specs that we need specifically for a solar array, those are new concepts. So we can make sure to talk specifically about those this morning. If anyone has a specific question about either selecting an inverter or determining the power requirements, please place that in the chat, or again, at any time today, please just raise your hand. and ask your question because we want to make sure that we clear up some of those questions or challenges before we move on. It will be really helpful, especially with the power requirements. Those are very foundational to the next unit on designing the solar array. We design the solar array to the power requirements of our pump. And so I want to make sure everybody feels very confident in finding those power requirements and understanding what they are before we move ahead. So again, please, all questions in the chat, or feel free to raise your hand. I have a few questions prepared for us today. And so again, these are just meant to encourage some discussion on some of the key topics that we've gone through in this unit. Um, I would prefer to answer your questions. So if you do have questions, please make sure, again, I'm going to kind of be a broken record. Please make sure you put those in the chat or raise your hand. This time is an opportunity for you to get your answers to those questions. But in lieu of hearing any questions at the moment, I'm going to proceed through some questions that I've made for you, and hopefully that will kind of raise any challenges that you've had or any troubles that you found in the learning material. Okay, so first question, this is not a poll, this is either a type in the chat or unmute and speak, but what's the main purpose of a pump in our projects, in our solar powered water systems? If you could describe that, what would you say? Yeah, so Kate says to draw water from the well and fill the storage tank. Yep, that's a great answer. That is what we're using it for. That's a great answer. Anybody else have thoughts? What's the main purpose of a pump? Or maybe how are we using the pump to do that? How are we using a pump to draw water from the well? Yeah, so we've got one vote for supply water to the community. Yeah. Jerry says pumps convert electrical energy to mechanical energy to produce flow. That's great. That's a great definition of what pumps do. Yep, these are great responses, guys. Thank you. Um, yes, so pumps add energy. They lift water from the source to higher elevation. Yes, yep, that's a great answer as well. Yeah, and so pumps do this though by adding energy to the water, right? And so as Fury said, they kind of convert the electrical energy we give them into mechanical energy, and then we basically add that energy to the water. I know we don't always think of pumps as moving water as being a way to add energy because kind of don't always mix water and electricity, right? Um, but pumps essentially are adding energy to the water to lift it. As many of you said, we're lifting it from the water source to the storage tank or to the community. And so we're doing that by adding energy into the water. And so that can be a helpful analogy as we're talking through some of these power requirements and pump specifications to remember that what that pump is ultimately doing is it needs to add enough energy into that water to move it. Sometimes we move it long distances. Sometimes we move it through treatment equipment or up into a storage tank, and all that will affect how much energy we need to add to the water. And so that's what we calculated right in Unit 2 with total dynamic head. That is the amount of energy that we need the pump to add to the water to be able to move it. Yes, and so for solar powered water systems, we've got a comment in the chat to reduce the expenditure on electricity power. So yes, for solar powered water systems specifically, yes, our pumps can help us reduce what we need to rely on the grid. So yes, that's a good clarification as well for our solar systems. Okay. Okay, so you can answer this in the poll or in the chat, whatever you prefer. But when using a pump curve, what are you trying to confirm? We've got a few votes. We'll give a minute for others to vote as well. Okay. A lot of votes for B, the intersection of flow rate and TDH. That's great. Yes, ultimately that is what we are trying to find. And we got a couple votes for the pump size. And in some ways, yes, that is true because we are looking for a specific pump that's going to meet our requirements. So in some ways, yes, we ultimately are getting our pump size. But when we are specifically looking at a pump curve, we're looking to find one that matches the flow rate and the TDH that we've calculated for our system. Um, and so that will tell us whether or not that pump is able to produce that design flow at that head, and ultimately be able to produce the amount of water that we need. Yes, Kate, do you have a question?
Yeah, I was just curious, when you're designing the system and you find out you need X cubic per hour, where do you even begin to like find the pump that you need? Will a manufacturer kind of give you some guidance and ranges that you can look at first to then select the pump that you want to look at its curve, or how do you make that in between step of even knowing what pump to look at?
Yes, that's a really good question. So there's a couple of options. Some of us might work directly with a specific supplier who has a line of pumps that are available maybe in our country, in our region, and that supplier would probably have given us a booklet full of those pumps and their pump curves. So for some of you, that might be the case. You might have to physically go to maybe the distributor where you're located and ask them, hey, where are your pump curves or give me a pump booklet. Maybe that's the case for some of you. The other option is most pump manufacturers have an online selection tool. Um, we can look at it actually if that would be helpful. We can look at specifically Grundfos Product Center. So I actually had this pulled up the other day for a later question. But let's see, we can go back and I'll just show you quickly how you could look for some pumps if you needed to. And again, other manufacturers like Lowrance and Franklin also have sizing tools like this. Um, and so this one specifically is Grundfos Product Center. So if you type that into Google, you'll find it. And they have a couple of different ways to to size your pumps. I prefer this quick sizing, unless you know a specific um, product line that they have, which would be like the pump family or pump design. But I prefer quick sizing, and then I like to do it by pump family um, as kind of my second choice. And that allows me to select like the SP line is their submersible pump line, which is what we're using a lot for solar power water systems. And so then
Is
you'll
that
come
what
down. Go ahead,
pump
Kate.
family uses, like the style of pump, if it's submersible, if it's surface, if it's another
Essentially,
defining quality? Okay.
yes. So over here, you'll see once you put in your flow and your head, you'll also be prompted to put in the voltage. And so that for us, either if it's not a solar system, it'll be based on the electrical grid you have access to, or if it's a solar system, you'll likely base it either on that electric grid or on an inverter if you have an idea of what inverter. But once you enter those, you'll get to select your pump family. Um, and so the only tricky thing is they'll name it based on their product line. And so they won't just type submersible or surface. They'll name it according to their line. So SP for Grundfos is submersible pump. Um, but they also only give you the options that they have that fit your parameters on the left. Um, So yeah, so and you once you put in these parameters, you can size and it'll give you kind of a list of pumps that would work. Does anyone have questions about this page just to start about what you'd enter or um, how you might get some of these numbers? Has anyone used this before or similar software? I'm curious if those of you on the call either use an online software or if you have maybe a booklet from the manufacturer. How do you find your pumps? If anyone uses kind of a different method to find the right pump for their project, I'd like to see that in the chat. I know from our discussions this week, we have a lot of you who work directly with a distributor in your region. And I'd love to hear about that too, because I'm obviously U.S. based and I support a lot of teams in other countries, particularly like in Africa or in Central America. I typically am using this online software and then working with the local engineers to figure out, I found this pump, can you get it where you are? That's the can be the challenge with the online softwares, is you might find a good pump, but then you have to determine, can I get it where it's needed, which was part of the kind of discussion questions this week, right? Being able to get the pump that you need in the location that you need it. Okay, so we've had at least one learner use the one for Lawrence and Grundfos. So depending on what pump supplier you prefer or which one might have the pump that you need, both of those have good softwares as well. I've heard good things about Lawrence. I'm just not familiar with their sizing software. Um, but just to finish out the demo, I guess, you just hit start sizing and it will go through and based on your inputs, it will pull up a list of pumps that it thinks will fit your project. And so at the top, it'll put the pump that it thinks is the best fit. And so it'll give you on the right, you can see this preference index, and that essentially is Grundfost's opinion on which one is the best fit for your project. So at the top, it will put the 100, the one it thinks is the best, and then it'll give you a few of these parameters that you can look through. Some of these pumps might be very similar to each other. So like pump number one and number two are actually the same pump. One just has more stages. So it'll give you more flow at that head. Um, but you can look through here and it'll show you the flow rate it'll give you at the head that you've typed in, and you can kind of use that to make your selection. And you can click into any one of these pumps to get the full details. So that hopefully narrows down the pumps that you have available, but you'll still have to go through and make sure that it meets your needs or any limitations that you might have. So that's a great question. Thank you. I'm going to look at the questions that others wrote as well. These are great questions. I'm going to save these here. I think some of these we'll answer as we continue through the day, and they'll match up with some of the topics that we're talking about. So thank you to everybody who submitted a question. If you have other questions as we go, again, please raise your hand or type them in the chat. Okay, so we're going to do another kind of open-ended question. Um, so what are the key differences between a solar pump curve and a traditional pump curve? Any thoughts? I'm sure many of us are very familiar with the more traditional AC pump curves. Anybody remember how solar pump curves are different? I think I have some examples if that would be helpful. It might pop up. Oh, let me put up the examples. Kate, do you have another question? I'm just going to pull up some
Oh,
examples.
I was going to start answering the question.
Yes, please do.
Yeah, the solar pump curves, you have to identify your total dynamic head across all the various curves listed on the graph, where with the pump curve, the total dynamic head's on the y-axis. So it has like that extra step for the
Hmm.
solar versus the AC.
Yeah, that's great. Do you remember why it is that way for solar versus AC?
I think it's because you have to make sure that it can function within that total dynamic head like range that you had.
Hmm.
Um, because then it also like shows you like the power rating or whatnot too, like how much that would you would need from your solar power and everything else versus the AC pump curve. You're not really looking at that in that moment.
Hmm. Yep. Yep, that's great. And Wesley as well, thank you, has added in the chat that the solar curves include power for the pump. And yes, we don't see that specifically. So here's the examples. Thanks for patience. So on the left side, we've got the more traditional AC pump curve. And so we see head on the left and flow along the bottom. And then on the right, we've got the solar example. And so we actually have our flow on the left and our power on the bottom. And then each individual curve is a different head. And so yes, the biggest difference here, the reason they look like this is an AC pump needs consistent power. So usually from an electrical grid, it's getting, for the most part, consistent voltage and current and power, and it's only operating at that one level of power. That's how they're designed, essentially. But for the DC or solar pumps, because they're run off of the fluctuating solar that we get through the day, they have to be able to adapt. And so in the morning, they don't get as much power, but at midday, they get what we might call peak power. And so throughout the day, they're getting those different amounts. And we want to be able to look at how is that changing and how is that throughout the day, how is that changing? And so that's why our solar pump curves show us that at different power points, what the pump is going to do. Um, any questions about pump curves, how to use them, um, the data we can get from them? Okay. So we did talk a little bit about manufacturer software already. And so I'm going to put up this question. And we'll say, why is it risky to rely solely on the manufacturer's pump selection software? What are your thoughts? Very helpful tools, but why would it be risky to rely on them? Got a couple of responses. Let others answer. So we have a lot of votes in. Most of you say that it cannot evaluate design quality beyond the inputs. I think that's a great answer. That's what I would go with. We've had a couple votes for it doesn't include all the available options. That's true as well. You're going to get the results you get are going to be what the software thinks, right? It's going to give you the options that it think fits best, and it's only going to be for that manufacturer, right? So you might find a better option somewhere else. That's true. Um, but yes, just simply a reason not to trust it solely was be it can't evaluate the design like you can. You have your engineering judgment, your technical background. You will be able to find things that the software overlooks. And so we're going to put up an example of that. Um, okay, so when we were looking at the Grundfos website a few minutes ago, I put in the flow and head that we're using for Zamburi. This is the first pump that pops up. So this is Grundfos's 100 preference index recommendation for our system. But there's a reason that it's not a good fit. Can anyone, if you look at the curve or the data, can anyone figure out why it's not a good fit? Giving you a little bit of a tricky question. I want to see if anybody can find the issue with this pump. So just a couple things that we can look at on this graph. And so down here you have the flow rate that it says it will give you at the head that we've put in. So for Zamburi, we've got 192. So it says it's going to do 51 meters cubed per hour. Um, Anybody see an issue with that for Zamburi specifically? So in a lot of cases, um, it might not be a big problem, right? For our flow to be a little bit higher than what we have calculated in our design. But for Zamburi, what's our allowable abstraction? It's 48, right? We've chosen to use that as our design flow. For in this particular pump, having a flow rate from our pump that's going to be higher than that allowable abstraction is not going to be a good choice, right? We don't want to exceed that allowable abstraction, one for the health of the aquifer, but also because of local regulations too. So there's many reasons that we've discussed in that Unit 2 discussion about why you don't want to exceed that abstraction limit. And so that's a detail, right, that the software won't know. So I encourage you, even if you do use some of these online softwares, just pay attention to some of those details and make sure that the pump that's recommended is going to work for you. Again, in some cases, we might not be near our allowable abstraction. And so that 51 compared to 48 might not be a big problem. But in some cases, it might be. And other things that you might have to look at would be the diameter of the pump compared to the borehole that you have drilled, or just other parameters that the software won't know whether it's a good fit or not. But you will. Kate.
So is it always better to come in just a little bit under your design abstraction rate? Or I guess you can always go back to your assumptions and see the allowable abstraction percentage you used and everything else too, right?
Yeah,
To make that final decision. Okay.
yeah, absolutely. It will just depend on how close you are to that abstraction limit. So for Zamburi, we said there's an 80% limit, and that's what got us to 48. But if that original 60 was our max and that was our allowable, then this pump would work great. So it will just depend on where you are related to the abstraction. It's a great question. This one will tie in a little bit. So I'm going to go ahead and pop it up. Um, but if you do see multiple pumps recommended or multiple pumps meet your requirements, how would you choose? And you should be able to select multiple on here if you see multiple that you think are good selection criteria. And yes, we had a really great comment in the chat too as we're talking that the pump might not be available locally, and that makes it difficult for the maintenance and the spare parts as well. So yes, that's another good reason to not solely rely on manufacturer software, is it doesn't always tell us what's available locally. Um, and then, yeah, spare parts might not be available. The technical knowledge to help maintain or operate it might not be available. So yes, thank you. That's a great comment. So yes, if multiple pumps meet your design requirements, how would you choose? Okay, so a lot of votes, a lot for choose the pump with the highest efficiency. Yes, that's a great option. If you have multiple pumps that would work, it's definitely beneficial to choose the one with the highest efficiency. That's going to lower, ultimately lower the amount of power you need and then affect your array size and help to make that as small as it can be and as cost effective as it can be because your pump is more efficient. And so choosing the pump with the lowest power requirement is another good way to look at it, especially for our solar pumps, because it's very easy for us to see on the pump curve what that power requirement is going to be. And choosing the one with the lowest power requirement can help us in our later design. With all other things equal, the cheapest pump is a good option as well, of course, as long as it also is helping your system design in those other areas. We did have one question. One of the questions that came in was if we can't get the pump size we want, so for example, if the pump gives a flow rate that is too high, what should we do? And how can we control the flow rate of the pump? That's a challenging situation. Um, there are ways, gate valves and things that you can put on the outlet of the pump that could lower the flow rate. Essentially, what you're doing with something like a gate valve is you're adding another minor loss, right? You're adding um, to the amount of energy the pump has to overcome, right? We're basically increasing the TDH using something like a gate valve. And by increasing that TDH, we should lower the flow rate that's coming through our system. Um, so that can be an option if you're very, very limited. I'd say that would not probably not be the best practice to have to throttle your pump in that way. It really would be best to get a pump that's not gonna pump too high of a flow rate. But it also depends on what we mean by too high. So is it like we discussed earlier, is it too high for the abstraction of the water source? That's when we'd want to be even more careful. Or if it's just higher maybe than our design, maybe that's okay. It just depends on what that difference is and can we maybe just increase if the water source can support it, can we increase the size of our system a little bit to match the pump that we can get? Um, so yes, a couple options there. If it's a matter of exceeding the abstraction of the borehole, I'd say we would really want to try to procure a different pump if at all possible. And if not, try to look at measures that can um, safely kind of throttle back what that pump is going to do by kind of adding in more for it to overcome. Um, and otherwise, if we're not at the limit of our water source, potentially we could just size our system for that pump and what it's going to be able to do, and just maybe provide a little more water than we had planned on if the other factors align with that. Um, so hopefully that answers the question. Thank you for dropping that in our poll box. If you want to ask a follow-up question or if that didn't answer it, please let me know. Okay. All right. So why is understanding pump power requirements important? I know this gets pump power requirements gets very sometimes technical and very detailed. And I know, at least for me, I'm not an electrical engineer, and I'd like to skip over this portion of the design process personally. But I've come to kind of enjoy it as we've gone. But why is it important? So most of you say it helps us size the solar array. Yes. So once we've selected our pump, the next step is that we need all of those power requirements and its specifications so that we can design the solar array based on those specifications. So, yeah, so flow and total dynamic head are the two main parameters we use for pump selection. And then after that, though, we do need to understand power requirements in order to design that solar array. So, yeah, it gives us how much energy we need and helps us in the next step, which we'll get into next week on solar design. So I'll put this up. Maybe this will be helpful a little bit. Um, if you have questions about some of the power requirements or how to find them, please, again, just raise your hand or put them in the chat. Um, this little visual I find helpful is just explaining how the power is being used. Um, And so at the top, we have our motor power. That's kind of the highest amount of power that's in our system. It's the power that we are putting into the pump's motor. Um, so basically, from the solar array into the pump motor, that's what we consider our motor power. And then it's helpful to think of the pump motor and the actual pump as two separate pieces. They're connected, of course, but the pump motor is what takes the electrical energy and then turns it into mechanical energy, as Fury said earlier. And that's what gets transferred to the pump itself, because the pump is what has the moving parts, right? That moves the water and is physically adding energy to it by moving it. So that's what we call brake power. And then the energy goes into the actual water, right? And that's what we call the hydraulic power. That's the amount of energy that's actually transferred to the water. Um, and so I know this graphic can get like a little detailed, but hopefully it's just helpful to think through. We start with an amount of power from the solar array, but as we go, we have some losses and some losses. So as energy is transferred to the motor, to the pump, to the water, we lose a little bit of energy. And so those are things that we need to account for. And it's why there's specific terms that we have to look for, like motor power, um, so that we can make sure we're overcoming all of those losses. Are there any questions about, again, about pump requirements, power requirements, um, how to find what you're looking for? This is our last poll question. So we'll go ahead and launch this one. But again, if you have questions in our last few minutes, please make sure you raise your hand or get those in the chat. Um, so when is an AC pump with inverter typically preferred? And so this relates to one of the questions we had in our poll box. Um, so yes, somebody asked, are solar pumps typically only for low demand systems? In our work, we always tend to use AC pumps with RSI. So that's a good tie-in here. So I'd like to see kind of what others think. When would an AC pump typically be preferred? Okay, so good responses, everybody. So most of you say that when high flow and head are required. Yes, that's typically when we would prefer it. A lot of people said when no solar panels are used. So yes, we typically use a AC pump if we're not using solar panels. For an inverter system, that implies we're typically doing a solar powered water system if we have that inverter. But yes, typically we're using AC pumps without the solar panels. Um, but when we're looking at an AC pump with an inverter compared to a DC pump, we are typically looking at high flow, high head applications. Solar pumps are fairly new still on the market. They are very simple, and they also typically are lower capacity. They just can't pump as high of a flow, as high of a head as many AC pumps can. Um, and that's just down to their design. They're improving. So Grundfos and Lawrence continue to come out with solar pumps that can do more and more. So the system size that you'll be able to handle with a solar pump is probably going to grow a little bit as the years go on and that technology gets better. But right now, there are just limitations to what we can do. So you'll typically see maybe a smaller rural village system is great with a solar pump because it can handle the flow and the head that it needs. And they're also just simple, good pumps. You reduce some of your equipment because you don't need that external inverter, and the system can just be simpler with that solar pump. And that's a great application. So kind of small to medium size projects. And then when you start getting into larger, maybe kind of urban projects, or a lot of us work in like a refugee context. So think Zamburi, that kind of example. That's where the AC pump with inverter is going to be probably a better fit because you're likely just not going to find a solar pump who can do that kind of head and flow requirement. So any questions about that when you might choose one over the other? Um, all right, well, we are about at our time, so this is maybe a last call for any other questions that you might have. Um, if you have any questions on your design tool, did everybody get step 4 done? Did you have any challenges? Oh, Wesi, that's a great question. So Wesi's asked, is it better to use two DC pumps instead of one AC? That's a very good question. So I've definitely designed projects in the past with two DC pumps instead of an AC for a couple of reasons. One, again, because they're simple. They're very somewhat plug and play, you could say. You don't need that inverter and some of that extra equipment. That is one more thing that could maybe break or be hard to procure. Um, and so, yes, depending on the flow you need, you might be able to just use two DC pumps. And what you're probably going to have to do is a design comparison, right? You might have to design both options and look at cost, look at equipment, what can you procure, what can the community maintain, what spare parts can you get. The other thing you'll have to consider if you want to do two DC pumps, if you're putting those in a borehole, can they fit? You'll typically have to stagger them a little bit and make sure that the overall diameter of your borehole can fit those two pumps together. So a couple things you'll have to think about, but definitely an option that I know has been done as well. And again, it just comes down to um, what kind of complexity do you want in your system? Do you want to avoid kind of the extra inverter equipment? Um, or do you just want to do one pump? So that's a good question. All right. Any other questions or any challenges with your design tool with step 4? So yes, next week we're going to start on Unit 4, which is designing the solar array. So we'll take all those power requirements that we have learned about in this unit and use them to design our solar array. We're giving 2 weeks for this unit because it is a lot of information, and it's for most of us what's new. A lot of us might be familiar with water system design in general, but the solar array might be new to us. So you get 2 weeks so you can move through it nice and slowly if you need to. Um, and hopefully that'll give you plenty of time to kind of absorb all that you're learning. It can be a lot of calculations. Just know that we have shown all of the calculations in the course. We want you to understand how they're done, but it is a lot of very repetitive calculations, as you'll see when you go through the material. And so that's where we've provided the design tool to help with all the repetitive calculations. We don't expect design engineers to be doing all these calculations by hand all the time, but we do walk through them in the course once so that you can see what's happening in your design tool. So hopefully that's helpful. Don't get too overwhelmed as you're walking through that material with the equations, but just know that we want you to understand what's happening behind the scenes of your tool and how you would do it if you needed to by hand. But hopefully you won't need to ever do it by hand. It can be tedious. Okay. Thank you so much, everyone. Are there any final questions? Anything else that I can help support you with? Please let me know. If you think of something after this call, we have the Q&A forum or the WhatsApp community. Feel free to type questions in there. If anyone has challenges with the final exam after today, we hope that that's been fixed as of yesterday. But if you have challenges with that too, please again, just reach out. We're here to help you through this course. Okay, well, I appreciate everybody joining today. Thank you so much, and hopefully we'll see you next week as well.
Yes, thank you, Jessica. Bye bye.
Thank you. Bye.